Hello everyone, Mary here, and we're going to do a couple more Chapter 2 homework problems. So we're going to begin this video with number 8. A car slows down uniformly from a speed of 21 meters per second to rest in 6.00 seconds. How far did the car travel in that time? So first thing we do is write down everything we know from the problem. So it slows down from a speed of 21 meters per second. That is the original velocity of the vehicle. When you write this down, make sure you include units. To rest, make sure your brain picks up on things like to rest. That is the final velocity. In 6 seconds, that's the amount of time that this motion took. How far did the car travel? Now, how far is an indication that they want to know displacement, and displacement is x. You set things up in this manner so you can look at your variables and then you compare this to your list of equations to determine which equation you're going to use. Now, which equation has VO, VF, T, and X in it? I would choose X is VF plus VO divided by 2 times time. And I'm looking for X. This is looking for X, so no algebra is needed. X is going to be my final velocity of 0. Original velocity, 21 meters per second, divided by 2 and a time of 6 seconds. I forgot my second over here. I'm now going to pick up my calculator, and when I do this, I'm going to have 21 divided by 2. Order of operations, do things inside the parentheses first, entered, and then times 6, and the displacement should be 63, and the units on that should be meters. Let's take a look at where the units come from. Meters per second, and I'm multiplying meters per second times seconds. Seconds are going to cancel. I'm ending up with displacement units, and my answer is 63 meters per second. Onward, we're going to go to problem number 9. And number 9 says this: for the previous problem, at what rate did the car decelerate? So let's go through and look at that. We have all of the same variables that we had above, and if you recall, we have no equations in physics for deceleration. So what I'm looking for is acceleration, but because it's slowing, I'm going to probably end up with a negative number for my acceleration. So if I'm looking for A, I have VO, VF, time, and now I also have X. I have a whole variety of equations I could use. What I tend to do is, if possible, I tend to avoid using the value that I just calculated. In case I made an error, I'd rather not carry that through. So what equation has VO, VF, T, and A in it? Well, the equation is VF plus VO. VF equals VO plus AT. Came out of my brain funny. And I'm looking for acceleration, so I'm going to have to do a little bit of algebra. To get acceleration alone, I'm going to subtract VO from both sides. So I'm going to end up with VF minus VO equals AT. To get acceleration all by itself, I'm going to divide both sides by T, and that's going to give me an acceleration is going to be VF minus VO, VF minus VO divided by time. Now I'm going to take the data from that previous problem and put that in. My final velocity was 0. The initial velocity was 21 meters per second. All of this happened, let me double check, make sure I don't have a wrong number. All of this happened in 6 seconds. So I'm going to go back. All of this happened in 6 seconds. And so now I pick up my calculator. 21 divided by 6 gives me 3.5, but I have 3 sig figs and 3 sig figs, so this is going to be 3.50. It's an acceleration. It should be meters per second squared. And I forgot something, and I can hear you yelling at me. There is a negative sign there, so my acceleration is going to be a negative 3.5 meters per second squared. Where did those units come from? meters per second divided by seconds gives me meters per second. Invert and multiply 1 over seconds, meters per second, seconds times seconds, seconds squared. So this is a check on my algebra, and I did that correctly. That is the rate of deceleration for the vehicle. Onward, let's do another one. Problem number 10. A truck covers 40 meters in 8.5 seconds while smoothly slowing down to a final velocity of 2.8 meters per second. What was the truck's original speed? So let's write down what we know. We're going to start with part A, and we have a displacement of 40 meters, and it covers that 40 meters in a time of 8.50 seconds, and it has a final velocity, V final, of 2.80 meters per second, and the question is, what was the truck's original speed? VO is question mark. Now you do this step so you can gather your variables, look at these, look at your equation list, which equation has x, t, vf, vo. I personally would choose x is Vf plus Vo divided by 2 times T. And I'm solving for Vo, so I'm going to have to do a little algebra. So here goes. To get Vo alone, first thing I'm going to do is I'm going to divide both sides by T. Do something on one side of an equation, go ahead and it'll do it on the other side. So x over T equals Vf plus Vo divided by 2. Now I'm solving for VO, so now what do? Well, I'm going to have to get this 2 out of the bottom of this fraction. How do I do that? I'm going to multiply both sides by 2, multiply this by 2, multiply that by 2. The 2's are going to cancel. I'm going to end up with 2x over T is Vf plus VO, and I still want VO alone, so how do I get VO alone? I am going to subtract Vf from both sides. So if I subtract minus a Vf from both sides, that's going to cancel it on the right, and this is all going to look like, and I'm going to put the thing I'm solving for on the right because that's kind of the way it's done. Original velocity will be 2x over t minus that Vf, and now I'm ready to put numbers in. I've got my algebra done. So 2 times my 40 meters, it went 40 meters is its displacement from up here, divided by a time of 8.50 seconds, minus a final velocity of 2.8 meters per second. And I am going to go ahead and get an answer for this left-hand side, and that's going to be 2 times 40 divided by 8.5. So all of this will end up being 9.41 when I carry this out to 3 significant figures, minus 2.8 meters per second, so minus 2.8 on my calculator, and I end up with a final velocity of 6, oops, I said final. Oops. I'm solving for original. I'm solving for original. I'm solving for original. I said the wrong thing, didn't I? VO is going to be 6.61 meters per second is going to be the original vehicle's velocity. There is a part B. Let's go back and take a look at part B. What is the truck's rate of acceleration? So let's go find the rate of acceleration of this truck. Now that I have all this, I'm going to have to grab my eraser and erase a little bit so I have some room. And I'm going to do that right here. Musical interlude while I erase. Okay, now I am going to look for the rate of acceleration. Acceleration equals question mark. Now that I also know the original velocity is 6.61 meters per second, I found that down here. What equation can I use? As I mentioned before, if I have a choice, I prefer not to use something I just found, but this would be awfully messy to solve for acceleration not using the VF and VO, so I'm going to go simple. Let's use this equation. VF equals VO plus AT. I'm going to solve for acceleration. So I'm going to subtract VO from both sides. VOs are going to cancel. I'm going to have VF minus VO equals AT. I want to get acceleration alone. I'm going to divide both sides by T, divide both sides by T. Acceleration will be final minus original divided by time. So the final velocity was 2.8 meters per second minus original, which was 6.61 meters per second, and all of this happened in 8.50 seconds. So what was my rate of acceleration? My rate of acceleration, when I now pick up my calculator, is going to be 2.8 minus 6.61, enter, divided by 8.5. I hit the wrong button. Sorry about that, guys. I got to do it again. 2.8 minus 6.61 equals, divided by 8.5 equals 0.448. And because of the fact that this is final and the original is bigger, this is a negative 0.448 meters per second squared because of the fact that this vehicle is slowing. That's what that negative sign tells us. All right, that will do for this video, and we will see you next time. Bye-bye.